So far, we have studied that some of the liquids like distilled water, kerosene, etc. are non-conducting. The conductivity of non-conducting liquids may vary when they combine with other liquids. Combination of two liquids is called an electrolyte. Collect the required materials such as 3 containers, lemon juice, copper sulfate, salt, distilled water and the tester on the table. Take a container and pour some distilled water in it. Add salt to distilled water and label it as container 1. Now take another container and pour some distilled water in it. Add some copper sulfate crystals in it and label it as container 2. Take another container and pour some distilled water in it. Add lemon juice to distilled water and label this container as 3. Take a spoon and stir the 3 containers so that they form an electrolyte. Take the tester and pour distilled water in it. Observe whether LED glows or not. Repeat the activity with the electrolytes in the container 1, 2 and 3 respectively. Observe whether LED glows or not and tabulate the observations. Wash and wipe the pins of tester after testing with each liquid. We have observed that LED does not glow when distilled water is used. But when the electrolytes in container 1, 2, 3 are used, then LED glows. We have learned that conductivity of distilled water has been increased when acids or some salts are added to it. The distilled water is pure form of water and is a bad conductor of electricity. When salts or acids are added to it, the electric current passes through, making it a good conductor. The water from sources like taps, hand pumps, wells, etc. are not pure. They contain some minerals which are useful for our health and act as good conductors of electricity. Hence, we are advised to not touch the electrical appliances with wet hands. Activity 4. Chemical effect of electric current. Collect the required materials such as LED, dry cell, 1 or 2 potatoes, copper connecting wires on the table. Take a knife and cut the potato in 2 halves. Take a wire and insert one of its end in the potato. Connect the other end of the positive terminal of the battery. Take another wire and connect its one end to the negative terminal of the battery. Connect the other end of that wire to LED's short LED. Now, take one more wire and connect its one end to LED's longer LED. Insert the other end of the wire into the potato at distance about 1 cm away from the first wire. Leave the setup for 20 to 30 minutes. Observe the changes on the potato. We observe a greenish blue spot around the wire that is connected to the positive terminal. No changes are observed around the wire that is connected to the negative terminal. From this activity, we have learned that greenish spot on the potato is due to chemical change in it. The chemical change is caused due to the electric current passing through the potato. The electric current can cause chemical reaction in vegetables, fruits, etc. This property can be used to identify the positive and negative terminals of the battery if it is packed inside a box. How was the first cell made? The battery is made up of dry cells. Before the invention of batteries, other sources were used to produce electric current. Around 400 years ago, people in Europe have started experiments to produce electric current in different ways. Luigi Galvani, A biologist from Bologna, Italy, conducted experiments with legs of dead frogs and concluded every time when electricity flowed through them, they are twitched. He stated that all living beings contained electricity and it was the main source of life. Later, Alessandro Volta of Italy conducted experiments with different liquids instead of frogs' legs. After all experiments, he found a way to steady source of electricity. In the year 1800, he made his first cell with the zinc and copper plates dipped in sulfuric acid. The first cell was named as Volta cell in the honor of Alessandro Volta. This invention had made him famous in the realm of science. The word voltage is derived from his name. Activity 5. Electrolytic cell. Place 2 injection bottles to rubber caps, metal strips of copper and zinc, dilute sulfuric acid bottle, LED and connecting wires on the experimental table. Zinc metal strip is obtained from the dry cell and copper strip is available from copper wires used in home. Make sure that the dimensions of strips should be 2 mm wide and 5 cm long. Take 1 copper strip and 1 zinc strip. Insert them in 1 rubber cap vertically. Once again, take 1 copper wire and 1 zinc strip. Insert them in another rubber cap vertically. 2 metal strips in both the caps should not touch each other. Pour the dilute sulfuric acid in both the injection bottles. Fix the rubber caps with metal strips to the injection bottles. Take a wire and connect zinc strip of one bottle to copper strip of the other bottle. Now take an LED. Connect the short pin of LED to copper strip in one bottle with a wire. Connect the long pin of LED to zinc strip in another bottle with a wire. Now LED does not glow. Then reverse the LED connections and observe the changes. We observe that LED does not glow in the first connection, but when the connections are reversed, LED glows. Also, we observe that bubbles forming on the copper rod because the zinc is dissolved in the sulfuric acid. We have learned that small electric current is produced in the above electrolytic cell. The zinc dissolves in the sulfuric acid and accumulates on the copper. In the activity, we have noticed that electric current is passed from copper strip to zinc strip. The strips used here are also referred as rods. These rods are known as electrodes and the solution of dilute sulfuric acid is called electrolyte. Here, the chemical energy is converted to electric energy by the process called electrolysis. Electrolysis is a chemical process in which a substance either in its molten state or in an aqueous solution is decomposed by passing the electric current. The entire setup in which the electrolysis is carried out is called electrolytic cell. The electrolytic cell consists of electrolyte, anode, cathode, battery and wires. It is also known as voltmeter since it generates voltage at its 2 terminals. Electroplating. We observe few of the objects like wristwatches, bike handles, screwdrivers, pad clip, cycle rim will be shining when they are new. As time progresses, or sometimes if these are scratched accidentally, the shine will be lost. We can see another layer inside the coating with dull surface. The difference in 2 layers can be easily observed. The top layer is shiny and the bottom layer is the dull surface. This is due to loss of shiny coating on the dull surface. The dull surfaces are coated with bright coatings. Electroplating is a process in which electric current is used to reduce dissolved metals cations so that they form a coherent metal coating on an electrode. Lab Activity 1. Electroplating. The aim of this activity is to coat an iron key with copper by electroplating. The materials used in this lab activity are a copper plate of size 2 cm and 5 cm respectively, crystals of copper sulfate, key made of iron, glass beakers, switch, water, dilute sulfuric acid, battery and connecting wires. Take a beaker and pour some pure water in it. Take some crystals of copper sulfate and dissolve them in the beaker. Leave the solution for a few minutes until a deep blue color, the concentrated solution, is achieved. Now, take another beaker and pour the concentrated solution in it. Add a few drops of dilute sulfuric acid to the concentrated solution. Make a note that acid helps in increasing the conductivity of electrolyte. Take a wire and connect its one end to the iron key. Connect the other end of the wire to one terminal of a battery. Take another wire and connect its one end to the positive terminal of the battery. Connect the other end of the wire to one terminal of a switch. Take one more wire and connect its one end to the other terminal of the switch and other end to copper plate. Now, hold the copper plate and iron key and suspend them in the copper sulfate solution. The copper plate and iron key should not touch each other. They must be separated by a little distance. Now, on the switch for 10 minutes and observe the changes in the beaker. Switch off the circuit and take out the iron key. We observe free ions of copper in the copper sulfate solution are drawn to electrode connected to the negative terminal of the battery. The iron key is coated with shiny brown color because of the electroplating process. We have learned that metals like iron are affected by atmospheric humidity, carbon dioxide, etc. So, they are coated with superior metal like copper that are not affected by these factors. Requirements of fine electroplating. Electroplating is the process in which one metal is coated with another metal. In this process, generally, inferior metals that are affected by atmospheric humidity, carbon dioxide, etc. are coated with superior metals that are not affected by these factors. There are some requirements to achieve fine coating. They are: greasy matter should not be present on the object that is to be electroplated. Object surface should be rough, which enables the metal to deposit permanently. Adjust the concentration of the electrolyte to get smooth coating. The current that is passed through the circuit should remain same throughout. Uses of electroplating. Electroplating is used in the industry for coating the metal objects with a thin layer of different materials. For example, iron metals coated with nickel or chromium to avoid corrosion. Not only iron metals, machinery parts are also coated with chromium to protect from corrosion and to give good polish. Electroplating is done with a view to repair the worn out parts of machinery with suitable metal. It is also used in ornamentation and decoration like tablewares, decoration pieces coated with silver or gold, etc. Tin coated iron cans are used to preserve the processed food because tin reacts less with food than iron. Zinc coating on iron prevents from corrosion and formation of rust. Hence, iron used for the bridges and automobiles is zinc coated. Dear children, with this, we come to the end of our chapter 9. Please complete the assigned tasks. Read the lesson for better understanding of the concepts taught. What is electrolysis? Is plastic coated by the process of electroplating? Why? Thank you.